Andrew can wash a car in 40 minutes. Duke can wash the same car in 30 minutes. To determine how long it would take them to wash the car if they work together, we set up the following equation. T over 40 plus T over 30 equals 1, where T is time and solve for T. One inlet pipe can fill an empty pool in 8 hours, and a drain can empty the pool in 12 hours. To determine how long it would take the pipe to fill the pool if the drain is left open, we set up the following equation. T over 8 minus T over 12 equals 1, where T is time, and then solve for T. Two different water pipes are used to fill a pond. It takes 12 minutes to fill the pond when both water pipes are used. Meanwhile, if each water pipe is used alone, one can fill the pond 10 minutes faster than the other water pipe. To determine how long it would take each water pipe to fill the pond alone, we set up the following equation. 1 over T plus 1 all over T plus 10 is equal to 1 over 12, where T is time, and solve for T. These are examples of real-life applications of rational equations. An equation containing one or more rational algebraic expressions is called a rational equation. The multiplication property of equality can be used to reduce a given rational equation to a linear or quadratic equation. We need to take note of the domain of the variable so that extraneous roots, if they exist, are identified and excluded from the solution set. The domain of a rational equation is the intersection or overlap of the domains of the rational expressions in the equation. An extraneous root is a solution of a transformed equation that is not a solution of the original equation because it was excluded from the domain of the original equation. Let us take a look at the following examples. In example 1, we are given 2x over 15 minus 1/6 is equal to x over 5. Since the denominator of each term is never 0, the domain of the rational equation is the set x such that x is an element of the set of real numbers. Our solution will be as follows. Given the equation, we apply multiplication property of equality. That is, we multiply both sides of the equation by the least common denominator, which is 30. We apply distributive property of multiplication over addition, and then simplify. We apply addition property of equality. We subtract 4x from both sides of the equation. Finally, we apply multiplication property of equality. We divide both sides of the equation by 2. Note that negative 5/2 is an element of the domain. Therefore, the solution set of the rational equation is the set containing negative 5/2. This can be verified as follows. Indeed, the solution set of the given rational equation is the set containing -5 halves. Let us take a look at example 2. We are given the equation 5 all over x minus 3 equals 4 all over x plus 2. First, we need to determine the domain of the rational equation. We look for the values of x that will make the denominators equal to 0. Note that x minus 3 is equal to 0 when x is equal to 3. On the other hand, x plus 2 is equal to 0 when x is equal to -2. The domain of the rational equation is the set containing x such that x is an element of the set of real numbers and x is not equal to -2 and 3. Next, we solve for the rational equation as follows. Given the equation, we apply multiplication property of equality. We multiply both sides of the equation by the least common denominator, which is the product of x minus 3 and x plus 2. We simplify both sides of the equation. We apply distributive property of multiplication over addition on both sides. We also apply addition property of equality. We subtract 4x from both sides of the equation. Lastly, we again apply addition property of equality and subtract 10 from both sides of the equation. Note that -22 is an element of the domain. Therefore, the solution set of the rational equation is the set containing -22. We can verify this as follows. Clearly, the solution set of the given rational equation is the set containing -22. Let us now consider example 3. We are given the equation 2x minus 16 over x equals 4. Again, we need to determine the domain of the rational equation. We look for the value of x that will make the denominator equal to 0. Note that the denominator will only be equal to 0 when x is equal to 0. The domain of the rational equation is the set containing x such that x is an element of the set of real numbers and x is not equal to 0. Next, we solve the rational equation as follows. Given the rational equation, we apply multiplication property of equality. We multiply both sides of the equation by the least common denominator, which is x. We apply distributive property of multiplication over addition on the left-hand side of the equation. Then we simplify. We apply addition property of equality and subtract 4x from both sides of the equation. We also apply multiplication property of equality and divide both sides of the equation by 2. We factor the quadratic trinomial. We apply the zero product theorem as well as addition property of equality. Note that -2 and 4 are elements of the domain. Therefore, the solution set of the rational equation is the set containing -2 and 4. This can be verified as follows. If x is equal to -2, we have the following solution. We apply substitution and simplify. Likewise, if x is equal to 4, we also have the following solution. We again apply substitution, then we simplify. Indeed, the solution set of the given rational equation is the set containing -2 and 4.